talk to you about dealing with motor control circuits when you have two loads wired in series. It is a common practice when people are starting to learn about motor control that they will try and put two loads or coils in series, and later on they discover it doesn't work. Today I want to talk to you about the practical side of things, as well as I've got a demonstration circuit set up. Now, right here on my whiteboard, I've drawn an atypical circuit where it is serviced by a control transformer. We have a control fuse and a 3-wire control station, specifically a stop and start push button, as well as a holding contact. Now, what we've done is I've taken two relays, and they're depicted in this illustration as being in series with one another. One of the reasons why we avoid a series circuit when it comes to motor control is that the voltage drop across each of these loads adds up to being lower than the applied voltage in the circuit. In this case, we have 120 volts on the control transformer. Now let's write that down. 120 volts. From our lab projects here at Cambrian College, my students will have discovered that it takes a minimum of 80 to 85 volts in order for this to function. Well, if I've got two of these relays that are identical in construction and they have the exact same coils, that means then that the second relay is going to require 80 to 85 volts to function. Well, if I add, even on the lower side, 80 plus 80 equals 160 volts. Well, with only an applied voltage of 120, I'm short 40 volts. Now, in my lab, I've already organized a demonstration. And what I've done is I've actually put in 2 voltmeters to measure the voltage drop across each of these coils. And we're going to examine how this circuit actually reacts in real time. So stay tuned. We're going to set up the workstation and we're going to be right back. Now here we are at the workstation, and I've already got the power supply pre-wired. I have a control transformer as per our diagram, a stop and start push button, and here I've got the 2 contactors. Now these contactors require 120 volts, which we're going to get from the control relay. And to complete the circuit, what we're going to do is wire the start push button into the coil of the first contactor, out of the coil of the first contactor into the coil of the second contactor, and then I'm going to complete the circuit and going to X2 of the transformer. Now, I could opt to put in the holding contact, and why don't we? So from one side of my start push button to one side of a contact, from the other side of this contact to the other side of the start push button. The only thing that remains now is I want to go and take voltage readings of the voltage drop across each of the coils when I energize this. So let's do that. I've got the voltmeter set on a 125 volt range, and we're going to take the voltage drop across the first relay coil for my first meter. The second meter is going to read the voltage drop across the second contactor coil. Now, all we have to do is energize our power supply and activate the circuit. Here goes. That humming or buzzing sound we hear is basically we do not have enough voltage going across both of these contactors as we saw on the whiteboard. We're actually coming up short of about 40 volts. Now I'm going to do this again, and let's take a look at the voltmeter displays. What you can see is that the first contactor is drawing a little bit close to 54 volts. According to the second display, my second contactor coil is pulling about 60. Now it doesn't matter the numerical value because of the fact I am still coming up short. Neither one of these coils is getting enough voltage in order for the armature to close the state and for the bridge contacts to change state. And this is the fundamental problem that we're trying to tackle. Now, some people may be a little bit skeptical. What if, instead of using 2 contactors, what if I change this up and I used a contactor and an indicator light? Would we get different results? Let's try it and see. So I have an incandescent indicator light here, and what we're going to do is we're going to substitute the indicator light for the second contactor. Just a matter of disconnecting it, removing it from the panel, and mounting our indicator light and wiring it in series. Now, let's go ahead and power the circuit a second time and observe what's going to happen. Here goes. You'll notice the circuit's not making any noise, but my indicator light did light up. When I look at the voltmeters, what we're going to see is that the first voltmeter display that is reading the voltage drop across the relay coil is drawing just about 5 volts. Over here, the lamp is drawing 115 volts. Why this is happening is because of the fact that the resistance of the pilot lamp is different from the impedance of the coil. Now, according to Ohm's law, the bulk of the voltage and current, the current is going to take the path of least resistance. And in this case, that was the lamp. So the lamp basically acted as a current shunt, and it was drawing the bulk of the voltage and the current to this load, leaving nothing for the contactor, which goes again to reinforce the concept that putting loads in series with one another doesn't function. In the end, the circuit won't work. Now, there's nothing wrong with putting control devices in series, but when you have devices that consume current or power, it never functions. And I hope that is the key takeaway. Anybody watching this will understand this. I hope you've enjoyed this segment, and if you like these videos, please hit like and subscribe to my channel. Looking forward to putting many more of these videos out there to help educate the community about electricity and motor control. Until next time, stay safe.